we really, like, we haven't focused on really engineering them much in terms of SynBio circuits or anything like that, because I feel like the pool of things that they already know how to do out of the box without us doing anything, it's massive, and we haven't even begun to scratch the surface. And before I engineer anything, I want to I want to see what they can naturally do. And I'll give you an example of a super stupid, like a simple model system for this that we developed recently, which is purely computational. Sorting algorithms, right? Like bubble sort, selection sort, that kind of thing, right? So the algorithm itself is about 6 lines of code. It's fully deterministic, completely transparent. There's no new biology to find there. There's no material physics. It's just like, it's very simple. You sort an array of numbers and there's an algorithm and it does that, right? So we made a version of this that's first of all, and these things have been studied for many decades, right? Every computer science student studies these, and we all feel like we know what they do because it's simple, it's transparent, it's deterministic. We feel like we know what they do. Okay, so first thing we discovered is that if you plot their movement in sorting space. So sorting space is just the question of how sorted are they. And so initially you start off down here because it's random, but then everybody gets to this one point at the end where everything is sorted, right? All these algorithms, if you crank through them enough, they're guaranteed to sort a string of numbers. So it sort of goes up like that. So one thing we did is we did something crazy. So we put a barrier in its place. What's a barrier? A barrier is a number that refuses to move. So you want to swap the 5 and the 7, but the 5 is broken, it won't move. Now, the algorithm doesn't know this. The standard algorithm does not ask, did the move succeed, right? It assumes that your hardware is 100% reliable. And when it's a swap, it assumes it's swapped, and you go on your merry way, right? There's no context checking, there's nothing. We didn't put in anything like that. All that happens is if you say swap and the cell is and the number is broken, it doesn't swap. That's it. And then you go on. What happens? So what we found is something remarkable. What we found is something that in either animal behavior or in autonomous vehicles you would call delayed gratification. What that means is when it gets to a barrier that it can't get past, what it's able to do is to get further away from its goal, go around and get to where you need to go. Now, right, like 2 magnets across a piece of wood aren't going to do that, right? The magnet's too stupid to because in order to go around, you have to get further, and all the magnet knows how to do is through the gradient, right? So it's not gonna,
that's right.
But you need a minute. It's a next level of cognition to be able to say, I'm going to take a loss now in order to recoup gains later on, right? I'm willing to step against my gradient. Well, it turns out these sorting algorithms can do that. It's not in the algorithm. There's nothing in the algorithm that says, if you run into trouble, backtrack. Nothing in it. This is the completely surprising emergent feature of this.
Yep, amazing. I'm surprised by that outcome.
I was shocked. I was absolutely shocked to see. People often say, when people try to define the difference between machines and living things, they say, well, machines only do what you tell them to do. Living things do their own thing. What looks like to me is that even these incredibly minimal things, there's the thing you make them do, which is what the algorithm says. And sure enough, they eventually do sort the numbers. But then there's these side quests that are like things they do that you never told them to do. And they're doing that kind of on their own. And we're not very good at guessing what those can be. But if we're creative, we can find them. And those are the spontaneous things that this is what like the wanting at that low level looks like, So I think for all of these minimal physical systems and our minimal biological systems, we should be looking for this stuff. We should be setting up assays to say, in addition to what we think you're going to do based on what engineering we've done, what else are you actually doing? What are the other goals that we never baked in?